Hello, everyone who is interested in topic tank twister detection in Ukrainian by using TDA as a part of Collins Conference 2023. The authors are Iryna Yurchuk and Olga. There are several aspects to need to study tongue twister as a part of text in human speech. First, for hard talkers, we need a tongue twister as an instrument to get better speech. For politicians, actors, and other public people, the main task when reading tongue twister is do it clearly and cleanly. And there is also one aspect is studying mechanism double attack when a speaker tries to pronounce two sounds at the same time, and tongue twister help us to avoid it. And practical aspects to have a detection tongue twister are following. First, rating complexity of existing texts for children who have a speech problem. We can analyze the sentences of text and check if it has the feature of tongue twister. The more tongue twister there are, the more difficult for such people a text is. And next, it's artificial generation of special type of text in Ukrainian language. It may be senseless, but it helps us to eliminating one or another problem. For example, improving the speech of for developing in it for younger children. And also artificial generation of tongue twister will make it possible to enrich the existing data set in order to apply NLPT for their detection. Nowadays, there are no more than 500, and we know that it's not enough to improve a good NLPT model. The purpose of our work is to propose an algorithm and its realization for tongue twisters detection in Ukrainian language that provides the understanding of text shape aspects with the possibility to implement it into machine learning. And the aim of research is to propose topological invariants, the calculation of which will be informative for understanding the nature of tongue twister to establish a set of data and the integration of which in a certain method of machine learning has the ability to distinguish tongue twister from simple narrative sentence. So let's start with backgrounds from persistent homologies. And there are several background structures: 0 simplex, 1 simplex, 2 simplex, 3 simplex. We can see it on figures. And on set of points, the union of them, such structures, can be constructed. It named Vittori's rate complex. And for every complex, we start to calculate their invariant. And after that, we start to research it. So we, in our work, we interested in the first persistent homology, capital H1 and their first betting numbers, which is a rank of capital H1. The mean of this invariant is the amount of cycles on the space. So we have to remark also that every figure in this space have different topological invariants. For example, the sphere is such type of figure that capital H0 equal Z, capital H 2 equals Z, and capital H1 equals 0, and the same for torus or Klein bottle. So let's present a proposed algorithm for detection tongue twisters in Ukrainian. Step 1. Every letter of the text is coded. We propose every letter correspond to a vector with 4 coordinates. First coordinates be an ordinal number of letter in the text. Second coordinate is the ordinal number of the word in the text which contains the letter, and it means a cluster, number of cluster in the text. And x3 and x4 is the ordinal number of alphabet ordered set of vowels and consonants respectively. On the right hand, there is a picture or diagram of tongue twister Bohdan beep розцвів дощ, буде бабі beep у борщ in three-dimensional space x2, x3, x4. x2 is the number of clusters that contains the letter and number of vowel and consonant. And then if the text consists of a capital N symbols, letters, then we correspond to a set of N capital N numbers of four-dimensional vectors. And we normalize it by standard function and map into a cloud of points. The next step, step 2, to construct on cloud of points, set of points by using epsilon 1, 2, 0, and epsilon k Vittori's Rips complexes, and for every complexes we compute in the first Betty numbers and obtain as output vector consists of k coordinates. And last step, step 3, we apply a previous step to obtain answer on question: is it tongue twister or not, by using a classifier. So for our experiments, we use dataset that consists of 100 Ukrainian tongue twister. We have to remark that there is no many tongue twister as a real part of language, and we also obtain 20 non-twisters or 30 non-twisters. Most of them is a part of some text details or another Ukrainian sentences. And the others considered two experiments, step 1 and step 2 are common for both, but in step 3 we use the decision tree classifier for experiment 1 and support vector machine classifier with Gaussian RVF kernel for experiment 2. In this slide, we present obtain a table with result. We present accuracy of decision tree and CVM classifiers. So we have to remark that following concludes. The best indicative tongue twister detection accuracy obtained with dataset 1 with a test size 10% for both classifiers. Tongue twister detection is stable with above average score with dataset 1 by CVM classifier. Tongue twister detection is stable with below average score with the following parameters: dataset 2 for decision tree classifier. And tongue twister detection turned out to be the most unstable with the following parameters as dataset 2 and decision tree classifier. As a conclusion, we have to remark that tongue twister detection in Ukrainian based on the consideration of a text as a sample of points and as a part of four-dimensional space, calculation of the first Betty number as topological invariants of existence of one-dimensional circle in it, and in implementation into machine learning is proposed. So in addition, we realized two methods of machine learning as classifier. According to our research, more accuracy is provided by support vector machine with Gaussian RVF kernel. And for further research, there are several ways to improve obtained accuracy of detection, as well as to improve the process of encoding words or letters, taking in account the sounds, the analysis of the sounds, as well as the complexity of pronunciation of the sounds, and can calculate another topological invariants that contain high order cyclomicity. Thank you for your attention.